Zach, is your straw bent?
No, Connor. It just looks like that because of refraction.
Refraction. What does that mean?
Refraction is when the light waves go from a slower medium to a faster medium, causing it to kind of look like it's bending.
Oh. So that'd be like if a truck was maybe going on from a road to mud, and these three tires are going to try to catch up to this one, but since it's slowed down, it's going to turn it sort of, and instead of coming this way, it's going to go on this route, right?
Yeah,
Oh, okay.
exactly.
Can you explain in this situation though?
Yeah, sure. Just hand me the whiteboard. All right, so this is the cup. This is the water. And like I said before, the water is a slower medium than the air. So here's the straw. And as you can see, the straw is actually not bent. So here comes a ray out. It's going up. And then the second it hits the air, it's going to go to the right. Just like in Connor's car example. And then so here's another one. This is the point of the light hitting it. So here's another ray going up, and then the minute it hits out, it's going to go to the right again, just like in Connor's car example. So say there's a person like over here watching down. They're going to see these two rays, and the rays are going to come back. They're going to visualize the rays coming straight back, and the two rays are going to be right here. So the person is going to visualize the straw being right here going to the right. So they're going to visualize it going this way. I'll fill that in for you so you can see better. So they'll visualize the straw going out like this. So when they're looking down, they're going to be seeing this split because of refraction.
Okay, Zach, I see what you're saying. So there's two things I've noticed so far about what must happen for refraction to occur. One, there has to be a change in speed as it enters a new medium, therefore causing the change in direction. So therefore, when the light goes from the slower medium to the faster medium, this changes speed and direction, allowing it to look as if it's bending. And number two, what I've noticed is that it can't be perpendicular, because if it's perpendicular, as we can see right here, it doesn't make a difference, because now the whole wave is going straight into it and slowing down the whole wave at once, not allowing for one side to go faster than the other or bend as we see it. Things that move faster in different mediums. Were you talking about the refractive indexes?
Yes, exactly.
Oh, okay. So what we know about refractive indexes is that water is 1.33 repeating and air is 1.0003. Therefore stating that things move faster in air than in water.
Yeah, because you want to be closer to 1.0.
And the only time that you can get to 1.0 is when it's in a vacuum, which is a perfect scenario.
Exactly.
Okay.
That's interesting, Connor. So how do you find something's refraction?
Well, what you're actually looking for is its angle of incidence or refracted angle. Now, an angle of incidence is the angle at which something comes into a new medium. Now, to find that, you use Snell's law. And to use Snell's law, which we can see here, you need to know three things. You need to know the first refractive index of the first medium. You need to know the angle of incidence that it enters into the new medium, which is the sine theta here. And you need to know the index of the second medium. So in this situation, we'd have air, and then the angle at which the straw enters the water. And then we'd have water down here, and now we are trying to find the angle, the second angle.
Here's a demo that includes total internal reflection and refraction. In this experiment, the stream of water carries the light and makes the light look as if it is bending. The light looks as if it is bending because the light is reflected within the stream, causing total internal reflection. This visualization of the light bending is also another form of refraction. So in conclusion, we learned that refraction is the bending of light as it enters a new medium. We also learned that in order for refraction to occur, there has to be two conditions. The first is that there has to be a change in speed of the light, and the second is that there has to be an angle of incidence, which means that the object can't be perpendicular.
We also learned to find something's refraction, you must use Snell's law. And to use that, you must have something's angle of incidence and its refractive index.
All right, thank you for listening.